rectangular window measures 54 inches by 24 inches. There's a 17-inch wiper blade attached to a 5-inch arm at the center of the base of the window, as shown in the figure. If the arm rotates 120 degrees, approximate the percentage of the window's area that is wiped by the blade. Well, we'll use a couple of pieces of information here. First, this wiped out section of the window is really part of a full circle with a hole in the middle, and we can interpret that as a large circle with a small circle subtracted from it in terms of their respective areas. We also have the big rectangular window, and if we're looking for the percentage of that window's area, we should multiply 24 times 54 to get the area of the big window. I'll do that now. So my calculator kindly informs me that that's 1,296. We'll use our units here. Those were inches times inches, so square inches. That's the area of the big window. Now we're going to need the area that's wiped clean. So I'll call that area for sub W for the window. The area for the big circle, I'll call that AC, can be calculated by doing I'll tell you what, I'm not going to do the whole circle, I'm just going to do the section of the circle. That section of the circle is formed by the 120 degree rotation. That's a fraction of the full 360 degree rotation that would make the big circle. So that fraction multiplied by pi r squared, in this case r is the 17 inches that goes out from the center of this big circle to the edge of the wiper blade, plus, let's see, plus the extra 5 inches associated with the arm of the wiper blade, squared. This is this portion of it is simply pi times the radius squared. That's the formula for the area of a circle. Now, some simplification is needed to compute an approximation for that. 17 and 5 is 22, and this simplifies to just 1/3. So I need to compute 1/3 times pi times 22 squared. I'll do that now. And that was 506.8 square inches. Now let's take away the area associated with the just the handle. So I'll use H to indicate the area of this portion of the window that's not being wiped. Well, using similar reasoning, we can say that that's equal to 120 degrees out of 360 degrees, so 1/3 again of a circle, times pi times 5 squared, where pi times 5 squared represents the area of this entire circle that's being cut out, but of course I only want to cut out 1/3 of that. That's the 1/3 associated with the 120 degree rotation. That's why I included this multiplier. Using my calculator again to get an approximation for that gives me approximately 26.2 square inches. If I add or subtract that answer from the 506.8, I obtain 480.6 square inches. That represents the portion of the window that is wiped by the blade. All I need to do now to finish the problem is to take that final area, I'll call it A sub wipe, take A sub wipe and divide by A sub window. That will give me the 480.6 divided by 1,296. Those are both square inches, and in the end that'll give me a decimal. If I multiply by 100%, I'll obtain the following. That's 37.1% rounded to the nearest tenth of a percent. So that's the fraction or the percentage of the Windows area that's wiped by our blade.